red table and yellow table. And yes, boys and girls, I kind of want you to face this way, okay? You're good. Everyone take a seat. Yeah, Jace, make a good choice, please. Okay, well, just make a good choice. This would be a good choice for you. Over here. Why don't you come over here? Got it? All right. It'll be a check if I see you doing that. Okay. I need everybody listening before I start. Everyone's attention. Romero. Romero, do I have your attention? Okay, boys and girls, so I want you to think back to the past week. We melted the crayons. We played with the paper, right? And what did we cause? What did we create when we did that? It's a new science word that we learned. Lex?
Physical change.
Physical change. Can everyone say that?
Physical change.
Physical change. Now, how did we know that we were creating a physical change? How did we know that? Farah?
By doing things to our paper.
By doing things to our paper. What did we change about our paper? What kind of physical properties? Jace?
We made it wrinkly.
We did, so that would be what? What would that be? What physical property would that be? If we made it bumpy.
That would be bumpy.
Yes, but what physical property is that? Are we changing the temperature when we make it bumpy?
No.
No, what? We're changing the what?
The size and shape.
Right, the size and shape, the texture. Okay, so when we're creating a physical change, we're changing how it feels, right? Texture, and also how it what? Mia? We change how it, yes, so how it looks and how it feels, right? Okay, but what about mass? What if we changed the physical property of an object, do you think its mass changes? Think about it. I want you all to turn to a partner and talk about this. When you cause a physical change, do you think that the mass changes as well? Here, you can talk to them, James. Romero, you can join them. Okay.
We have to go on the side. The flexibility.
Here.
The weight inside. I think how do we change it? Actually doesn't because how do we change the base?
Okay, so how did do you think that the mass changes?
How heavy it is? I don't
When you cause a physical change? You don't think so?
Do we change Aiden? Do we change?
Why do you think that?
Your thoughts
What do you think, Benjamin?
Romero has no part.
So do you think the mass changes? You think it does? What about you, Abigail?
I mean, we're not. No.
You think it does? Okay.
He doesn't want
All right, boys and girls, can we come back to whole group in 5, 4, 3, 2, 1. Romero, please move over here. All right, boys and girls, so can someone share with me what you and your partner spoke about? Austin?
I think the mass doesn't change because you're just changing the shape and not the size.
Okay. Austin thinks that the mass doesn't change. Any other thoughts? Ava?
Sometimes it changes, sometimes it doesn't.
Okay. Ava thinks sometimes it changes, sometimes it doesn't. It just depends. Anyone else? Does anyone disagree? Lauren? You disagree? So do you think the mass changes or not in that instance? No. Okay. Well, you know what? Let's test it out. Let's see for ourselves. So we're going to wave this can before. Yes. With our balance. With our balance beam. All right, now, I have all these Unifix cubes. I want to see what you guys think. How many Unifix cubes do you think will it take to balance out this empty can of Coca-Cola?
Whoa.
So, I'm going to take 3 guesses. What do you guys think? Parker, what do you think?
1.
You think 1, okay. Parker thinks 1. Anybody think differently from Parker? Carter.
5.
Carter thinks 5. All right, I can take one more guess. One more guess. Lacey.
10.
10. Ooh.
I think it's 5.
All right. These numbers are pretty different from each other.
I got 20. I just did 5.
All right, this is teacher talk time, and I can't start this until I have everyone out of voice level 0. Very good. All right, let's try 1. Okay. We're trying 2.
Nope.
Trying 3.
Ooh.
There we go. But is it there yet? No, and we're not there yet. I'm going to add 1 more.
4.
Let's let it balance out. Let's let it balance out. What's my answer? Oh, it is 4. What's my answer, boys and girls? 4 Unifix cubes.
No one was right. No, I was so close.
So,
But no one was right.
now we know the mass of this empty bottle of Coca-Cola. It's 4 Unifix cubes. But you know what? I'm going to create a physical change. I'm going to crush this can. Okay. So when I crush this can, what physical properties am I changing? I'm gonna choose quiet students with their hands raised. Okay. Vera, I am taking, yeah, because the sides are edgy, they're pointy. What else, Lauren?
It was probably like smooth throughout.
Very good. Okay, so let's see if the mass changes. Let's see.
What? It's the weight's heavier than the same.
All right, boys and girls. So did the mass change? No. No, it didn't. So why do you think that the mass didn't change? Lacey, why do you think the mass didn't change?
Because it still weighs the same and it's still just a bottle.
Because it's still the same thing. Did we take away from this can? Did we take anything away from it? Did it change into anything new? No, it's still a what?
Can.
It's still a can. Okay, so thumbs up close to your heart if you think that you understand physical change. Thumbs down if you don't. All right, boys and girls, so in a minute I'm going to be calling you back to your seats. Benjamin, that's your warning. Please sit down on your pockets. So you're going to come back to your seats, and you're going to get out this graphic organizer that I put in your desk, and you're going to color. You don't have to write. You're going to color and draw 3 examples of a physical change. Think of something that we haven't talked about. You know, I want to see what you know. So I'm going to be calling quiet, ready tables to go back to their desk. Yellow table, you may go back to your seats. Green table, you may go back to your seats. Blue table, you may go back to your seats. Yes. And red table, go back to your seats.